Okay, let's take a look at this hypothesis testing scenario. The data appears right there. Okay, so I'll read that. The average height of an NBA player is 6.698 feet. A random sample of 31 players' heights from a major college basketball program found the mean height was 6.72 feet with a standard deviation of 4.6 inches. Okay, with a alpha at 5%, is there sufficient evidence to conclude that the mean height differs from 6.698? Okay, so the first thing we have to do is state the hypothesis and identify the claim, and that's done right here. The null hypothesis given by H sub 0 is the statement that there is no difference between a parameter and a specific value. So H sub 0 colon, we say the mean equals 6.698 feet, right? That's the average height of the NBA player. Step 2, the alternative hypothesis, H sub 1, is the statement that there is a difference between a parameter and a specific value. So in this case, the mean height of players from a major college basketball team is different from the 6.698. So we would state that as H sub 1 colon, the average does not equal 6.698 feet, or the mean. All right, let me slide down. Step 3 says, well, actually you can see that just fine. Step 3 says, is the mean height of players from a major college basketball program different from 6.698 feet? So, we have the claim of the alternative hypothesis. Or in other words, the claim is the alternative hypothesis. So let me slide on down. Now, what we want to do in this case is use the z-test. And the z-test is a statistical test for the mean of a population, but it can be used either when n, which is the sample size, is greater than 30, or when the population is normally distributed and the standard deviation, the population standard deviation, is known. So the formula for the z-test is given right here. All right? Now, they've given us some information in feet and in inches. So I've put the information that they gave us in Excel so that we can do the calculation. All right, they gave us the sample mean as 6.72 feet and the hypothesized population mean is 6.698. If you wanted to convert that to inches, you would just hit multiply the value right there, which is given in cell D44 times 12, okay? And you can either look here to see the formula or look way up here, right there, okay? And then we do the same formula for hypothesis population mean if you wanted it in inches, but then they gave us inches for the population standard deviation. Right, if we slide back up here, see, they say standard deviation was already in inches. So we've got to go through the conversion. So in this case, what you need to do is take the 4.6 inches and divide it by 12 to turn it into feet. Okay, so now that we have everything in feet or in inches, we can do the calculation. So we convert it to 0.383. You know, I've just followed what they said here. I've done it in Excel. And then you use the formula for the z-test. Okay, so 6.72, the sample mean, minus 6.698, the hypothesized population mean, and we divide it by 0.383, the population standard deviation, divided by the square root of the sample size. Okay, so once we put all that information in, we come up with 0.32. And if you wanted to see how I did that in a formula, you can see I took the value of D44 minus D45, that's those two numbers, divided it by, and then we've got D46, the population standard deviation, but first I've got to calculate the square root of the sample size, which was 31. Well, to calculate the square root, you can use a square root function, but it's just as easy to take 31 and raise it to the power of a half, which is a square root function. Okay, and so I come up with the 0.32 that you see there. Okay, so now we know z value is 0.32. And so we make the decision, and the decision says the test value, 0.32, right, 0.32, does not fall in the critical range, right? It's not outside of either of the tails. So we should not reject the null hypothesis. And to summarize the results, we simply say, since the null hypothesis was not rejected, there's not enough evidence to support the claim that the mean height of players from a major college basketball team program differs from the 6.698 feet. Okay, so I hope you found that beneficial and helpful to you in understanding hypothesis testing.